This one's a little crazy. It's our last one for Unit 1. It says, find the perimeter of hexagon A, B, C, D, E, F. So that means we have to find the lengths of all those different parts. Like I said, when you're typically given a diagram, it's easier to use the Pythagorean Theorem to keep it organized than it is the distance formula. Alright, so what we have here, Pythagorean Theorem. A squared plus B squared equals C squared. We can say A is the horizontal distance, this is the vertical, and that's the slant distance, the actual distance. So what we have here, this says horizontal. It's a little fuzzy there for some reason, probably because of the lighting. Let me see if I can get something to help with that corner. I don't know. Does that help? Not much. Yeah, you can see it better when I do that though. Horizontal, vertical distance. Okay. So first, let's label all the different parts we need to see. Let's just go in order. A, B. Then we need to find B, C. C to D. D to E. Then we need to find DF. Then lastly, FA. Alright, so we need to find the perimeter, the distance around this object. First, let's do some highlighting. I'm not going to highlight AB because I only have 4 highlighters, but I'm going to do BC. Then I'm going to highlight the next one, CD. Then I'm going to highlight DE, green. Then I'm going to do DE. Did I forget EF? I forgot EF. DF. That's supposed to be EF. That's EF. The highlighting will help you guys see that. And then we need to find FA, which I'm just going to underline it with this purple and highlight that like that. Alright, well, first thing you really should do when working on these is try to identify if there's any vertical, horizontal lines. Slant, 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 slant. The only one that's vertical horizontal is AF. So it means we just got to count the distance. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I believe this one is 11 units. I'm going to write there just to confirm it. Try it one more time. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 units. Perfect. Well, first let's find AB. Let's find AB first. Let's go from this point all the way to here. So our goal is to reach this point. Start here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it should be 11 squared. But let me count it one more time. Remember, you can always do the ruler postulate for this as well. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 squared. Now we need our vertical distance. Well, that's not bad. Just 1 plus 1 squared equals c squared, c being the distance. We get 121 plus 1 equals c squared. 122 equals c squared, square root. You get 1 square root 122 equals c. So that's for AB, our non-highlighted section. We're just going to leave it like this. It can't be simplified because then it becomes 2 and 61 is prime. Our next one we're going to work on is BC. BC is our orange line. So I'm going to move from B all the way to this point for our horizontal, for our A. 0, 1, 2, 3. 0, 1, 2, 3. So 3 squared is where we start. Then we need to do our vertical. 0 to here. 0, 1, 2, 3, 4, 5, 6. So we get plus 6 squared equals the slant distance. 9 plus 36 equals c squared. 45 equals c squared. Square root. So right here I can kind of see that we can break this number down, so let's do that right here. 45 breaks down to 9 and 5. 5 is prime. 9 can be broken down to 3 and 3. So now 45 is broken down to square root 3 times 5. So we broke it down to prime numbers. You can kind of see it right here. When you have a square root to take out numbers, what you need to do is you need to pull it out pairs, because the square root of 9 is 3, so you pull out 3 from the square root. So our final thing would be 3 square root 5 is equal to c. So our distance of C, when we're looking for an exact answer, would be 3 square root 5. Alright, let's continue with this madness with trying to keep everything organized. I think that's one of the most important parts of this type of problem. Now we want to find the distance of CD. The horizontal distance, it's going to be from here to here. So 0, 1, 2, 3, 4, 5. So we have 5 squared. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Good, we have our horizontal distance. Now we need our vertical from here to D. 0, 1, 2, 3, 4, 5, 6. So plus 6 squared equals c squared. 0, 1, 2, 3, 4, 5, 6. We get 25 plus 36 equals c squared. What you get is 36 plus 25, be 61, I believe. Yep, 61 is equal to c squared. I know that's a prime number, so it can't be simplified. Square root both sides to get c by itself. Square root of 61 is equal to c. Write that down to 61. Now we're going to find the distance between D and E. So line segment DE, our green line segment. So we need our horizontal distance. I'm just going to count from E to D. D is all the way at this 10 point. 0, 1, 2, 3, 4, 5, 6, 7, 8. So right here we have 8 squared. 0, 1, 2, 3, 4, 5, 6, 7, 8. Perfect, so that's our spot. Now we need to find the vertical distance. 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's plus 8 squared. Oh, look at that. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We get 64 plus 64 equals c squared. We get 128 is equal to c squared. You square root it, and we want to simplify this one like we did for the 45. I know that one's going to get a little simplified. It's a little blurry right there. Move it. Let's see if I move it a little. Okay, I guess that's a little better. So what we do, 128 would be 2, and 64. And 64 could be broken down to 8 and 8. And the reason why we knew that is 8 makes 2 8. So you can pull out an 8. So now we know that the square root of 64 is 8. 128 becomes 2 times 8 times 8 equals c. Don't recommend not breaking down the 8s if you can't see that they're both the same. You can pull it out. So I see 2 has no pairs, but the 8s do. You pull out the 8, square root 2 equals c. So right here, that simplified is 8 square root 2. All right, we're on the home stretch now. We're on the home stretch. We are now looking for the distance of EF. So first with EF, we count the horizontal distance all the way to this 9 point. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like our horizontal distance is 11 squared. One more time. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now we need to find the vertical distance. 0, 1, 2, 3, 4, 5, 6, 7, 8 plus 8 squared equals c squared. 121 plus 64 equals c squared. Then you get 5, 8, 185 c squared, square root. I don't think this number breaks down. 185 by 5, no. So our final answer would be square root 185 equals c. And let's find the perimeter, the distance around this hexagon. So, what we have here is all the distance. So I'm going to add all these up, and that will be our actual. So our exact distance would look like this. Square root 122 plus 3 square root 5 plus square root 61 plus 8 square root 2 plus square root 185 plus 11. So that would be our exact answer. It's kind of a good idea to always have an exact answer because you don't want to round to the very end. So to finish this off, we're going to use our calculator. Okay, to get your exact or your estimate, let's get an estimate distance. It's not really an estimate, but we're going to the hundredth place, so we'll just say it is an estimate since we do have radicals. So you would do 122 square root plus, I'm just going to bring that in to make it easier for me, 45 square root plus 61 square root plus 128 square root plus 185 square root plus 11 equals, and we get 61.48 units. Okay, so let me just tell you what I did. With these two simplified ones, I changed them back to the original form to make it easier on ourselves. So 3 square root 5 is just square root 45. And then here is square root 128. Let's try this one more time. Just make sure our answer is correct. So I suggest you just use these so you don't have an error in the calculator, but you could do it either way if you have more of a WYSIWYG calculator. Let's try it one more time and we'll be finished. 122 square root plus 45 square root plus 61 square root plus 128 square root plus 185 square root plus 11. Well, we did it twice. Looks pretty good to me. Our answer should be 61.48 units. And that's all we got. All right.